In this video, we will take a closer look at what post-processed kinematic is. As real-time kinematic, post-processed kinematic uses observations from two GNSS receivers to achieve centimeter-level accuracy. One unit is static. This receiver is called the base station. Another one is rover, and it can move freely. The main difference between PPK and RTK is when the positional correcting takes place. To provide an accurate position in real time, the RTK mode applies all corrections in real time during the data collection. PPK resolves errors after all the data is collected. In PPK mode, there's no need for the connection between rover and base station while you're working. You only need to record raw GNSS data logs and use it for calculations in post-processing. The technique is widely used for drone mapping and for land surveying data collection. Using PPK for UAV mapping reduces the amount of ground control points you need. This saves you a lot of preparation time in the field and allows working on much wider and more difficult areas. PPK also provides a more reliable and simple workflow because you don't need to think of the constantly stable connection between rover and base. Besides, PPK allows longer baselines. Multiband GNSS receiver Reach RS2 and Reach M2 can work on distances up to 60 kilometers in RTK and 100 kilometers in PPK. Let's take a closer look at the PPK workflow. You need to have a base station and a rover. Both units should record raw GNSS data throughout the whole work process. This raw data contains all observations without any calculations. After the work is done, the logs from both the base and the rover are downloaded to PC for further post-processing to achieve centimeter-level accuracy. Remember, you don't always need to have your own base station. In many cases, there are local service providers who have their own base recording logs. You can simply use their raw data for the same time frame as your work. Check MLID docs to learn more about how to post-process and analyze PPK logs and solutions. Thanks for watching.